Exoplanets are planets that orbit around a star that is not our own sun. From our perspective here on Earth, they are very small, very dim, and very hard to find. We found over 4,000 of them, but we think there could be as many as 400 billion in our galaxy, let alone the entire universe. There are lots of different ways of finding exoplanets, but in this video I'm just very briefly going to go over one, the gravitational microlensing method. Now this method has its roots in Einstein's ideas about gravity, namely that instead of considering gravity as some mysterious, attractive force between different objects, rather considering it as the warping of space-time itself. So heavy objects warp this fabric of space-time more than lighter objects, and because of this warping, then objects, as they travel through space-time, will have their paths distorted or redirected. And that's not just objects, but also light. But how does this help us find exoplanets? Well, let's watch this short animation from NASA and I'll give you a quick explanation why. Here we have a very bright star that is emitting light in all different directions. Now watch the effect that this small star and its planet has upon the light rays emitted from that larger star. We can see that as it moves through them, the light rays themselves are bent and focused at times. Now let's re-watch that video, and instead of looking at the planet and the starlight, let's instead look at the graph on the bottom right. We can see here that as that star and its planet move through the light rays, there is a small tiny point where the gravity of the planet and the gravity of the star work together, and we end up with this very, very small peak. That peak can be used as evidence for an exoplanet. Thank you very much for watching this very brief introduction to gravitational microlensing. If you're interested in some other methods for detecting exoplanets, take a look at some of the other videos we've posted on our Twitter or on our YouTube channel.